Starting with this video, we're going to be covering a new topic. So we're going to start off with a new project. Just like before, we're in our Java projects folder. We're just going to create a new folder, and we're just going to call this one loops. We're going to go into the folder. We're going to go into the address bar here at the top, delete all the text, and type CMD. That'll launch the command prompt for us. And since we are in the loops folder, we are just going to run the Gradle init command. And that's the command that Gradle uses to start a new project. Again, we're going to go with an application. That's option 2. We're going to go with Java, which is the default, so just enter. We're going to go with no. We're going to go with Groovy. We're going to go with JUnit. And we're going to go with the default project name, the default source package, and the build was successful. So now I see I have all these files in here, so I can open up Visual Studio Code. And if you have the project open from before, you can close it, or you can just open a new folder. I'm going to navigate down. I want to go to Documents, Java Projects, Loops. So I'm in the Loops folder, so I'll just select Folder now, or I can go back to here, highlight Loops, and press Select Folder. And that's going to open up the project here in Visual Studio Code for me. And then I'm going to go in to App, Source, Main, Java, app.java. Okay, we look down here, we're still activating our extensions. Java looks like it's still loading. So while that wraps up, I'm just going to delete this string get greeting method. Remember, that's lines 7 through 9. Don't delete anything above this or below it. And then I'm going to delete this line out of main. Remember not to get your curly braces. We just want to delete line 9 right here. I'm going to save that file. And then I'm actually going to go in and delete this apptest.java file because I don't need it. And now I should be pretty clean in my environment. Let's see, it looks like Java's still loading. So this is the first time that we may have booted up Gradle and booted up this Java program, this Java project rather. So this can take a little while to boot up the first time. Notice we're importing the project, we're about 60% there. So while it's booting up, we're going to talk about kind of where we've been and where we're going. So far, we've talked about two big aspects of programs that we write in Java. One is that they are sequential, where sequential means we go line by line in order. That's kind of the default way programs execute. Okay, but we've also looked at branching, which is where we have conditional flow, or we can say it as multiple options. One way we can branch is with an if, else if, else, or with a switch statement. So ways to execute some parts of the code sometimes, but not all the time. Starting with this video, we're going to look at another structure that we use called repetition, which is where segments of code run repeatedly. So sometimes there's a section of code that you want to run more than once. And instead of writing the code over and over and over and over again, you can use a special structure called a loop in your code to achieve that effect. So while this is still finishing, notice that we're still wrapping up a few things with Gradle. I'm just going to write some example code here so we can get a feel for it. And I'm going to format this file real quick to make sure, there we go. That looks a little better. I'm going to get these back to where they go. Perfect. So if I have an integer value that I'm just going to call my value, I'm going to set equal to 0. And I want to know what is the value of my value. This is some code I could run. And let's say I want to increment it. And remember, in Java, one easy way to increment, we can do plus equals 1, or we can do plus plus will be another way to do it. And then I want to print out the value again. Okay, so if I were to run this code, it prints 0, then 1. But let's say I wanted to do this increment and print about, maybe let's say 5 times. Okay. So I have this. I can run this, and I get, all the way up to 5, which is fine. The problem is that if this got any more complicated and we wanted to repeat the same steps over and over and over again, the more complicated those steps are, the more issues we'll run into if we just copy and paste code. A good rule of thumb, especially for new developers, is that if you find yourself copying and pasting code in one part of your project to another part of your project, there's a very good chance that what you're doing can be done better. So that's not to say that you should never copy and paste, but copying and pasting is kind of an indication of something we would call a quote-unquote code smell. And that is spelled just like it sounds. And it's kind of a way of saying this kind of smells weird. This has a funny smell to it. This is something that we probably need to look more into. Okay, so let's say that we don't want to do all that. Well, there is a structure we have called a loop. And we use a loop to run the same code repeatedly. So one example of a loop is the while. And we'll say a few things about the while, but a while looks like this. Okay. So you'll see some things that look very similar to something you've seen before. If you say, hey, this looks kind of like the if that we saw when we first looked at conditionals, it is very similar. You have a keyword, while, you have a condition that it's checking true or false, and you have code inside of the curly braces. And what this means is that every time the while loop runs, it checks the condition. If the condition is true, it runs the code. If the condition is not true, then the while loop finishes and the program continues. So we say code only runs when condition is true. The difference between the while loop and the if statement is that the if statement checked the condition one time. If it was true, it was true. If it was false, it was false. The while loop checks the condition repeatedly until it is false. So if the condition is false the first time it checks, it only checks once. If the condition is false the 10th time it checks, then it will still check 10 times. It checks until it finds a false condition. Notice how we have the condition before the code. That's because the while loop is what we call a precondition loop, which means it has to check the condition before running. We'll see an example of a loop in the next video where it'll check the condition after it runs, and we'll talk about why you might want that. So here's an example of a while loop. And if I were to spell true right, this is a loop. There's no code in the body, so it doesn't do anything, but the condition is always true. So this is actually what we would call an infinite loop. And it's called an infinite loop because true is always true forever and ever. And if I wanted to print some text, I could say system.out.println, and we'll just say something simple like I'm stuck. So if I were to run this code, run Java, we see that I'm stuck is being printed over and over and over and over and over again without stopping. In fact, the only way to get out of this is inside your terminal window to press Control-C, and you'll get this little window that asks you if you want to terminate it, and we do. So that'll kill it, but otherwise it would just run forever. So sometimes you want infinite loops. It's rare, but there are definitely cases where you would want it. A good thing to mention here is that because loops can do stuff like this very easily, when you get into robot programming, at least for first programs like FRC especially, you will very, very rarely actually use loops. Loops are generally not something you're going to want to use in FRC programming. You'll use them more in FLL programming, maybe FTC programming, but FRC, the way the robot constructs are set up is you would almost never use a loop. The loop is handled kind of outside the code for you. So if you're doing FRC programming and you find yourself using a loop, you are probably doing something wrong, and you'll just want to double check what you're doing with somebody who might know a little bit more than you at the moment. Now, this isn't the only kind of loop we can do. We can make more interesting infinite loops. For example, I can say a condition here. My value is greater than 0. Now, if I start my value with a value of 1, and I run this code, okay, we printed the first line. You can't see it anymore because it went away. Then it says, okay, is my value greater than 0? 1 is greater than 0, print. So the condition was met, and so because it's a loop, we have to check it again. My value greater than 0. Well, I didn't change my value, so it's still greater than 0, so we have to print again. And it keeps doing that. So this is another infinite loop because my value greater than 0 will always be greater than 0 because we're not changing the value. So I'm going to stop this, and now we're going to do a little bit more work here. So instead of printing I'm stuck, I'm going to print just the value. So if I run this code, it's going to print 1 over and over and over again because the value started at 1 and it stays 1. So we're still in an infinite loop, so that's not really all that interesting. So one thing that's important and it's really two pieces. One is that the condition needs the ability to be false. So right now, my value greater than 0. That does have the ability to be false. We're not doing anything that would make it false, but I could definitely make my value not greater than 0. I'd have to make it a negative value, but I could do it. And the second is that code needs to modify something in the condition. So here's an example. Let's set our value to 10. Okay. If I run this code, run Java, it's going to print 10 forever. My value I could make this condition false. I'm not, but I could. And the reason that I'm not is because I have not followed the second step here. I need to do something in code inside of this block to modify my value. Well, I could add this line, my value plus plus. This says that every time the loop runs, increment my value. So if I run that, notice these numbers are just zipping right up. They're getting bigger and bigger because every time the loop runs, I add 1 to it. Well, if I started at 10 and I keep adding 1, I'm always going to be greater than 0. It's never going to go the other way. So I technically have the ability to make this condition false, and I am modifying something in the condition. I'm modifying my value. That changes every time the loop runs. But I'm not changing it in a way that gets me closer to flipping that condition. One way to think about these loops is to treat this condition kind of like a light switch. The first time the loop encounters it, it's going to be on or off. If it's on, it keeps trying the loop. And it's going to keep trying the loop until that on flips to off. And right now, 0 is kind of near where that off position is going to be. But when I take 10 and just keep adding and adding and adding to it, I'm getting farther and farther and farther away from 0. I'm never ever getting closer. So instead of going from on to off, I just stay on. So if I try, instead of incrementing, to decrement, so now my value is going to get smaller every time the loop runs. Let's see what happens when I run this. All right, this time the code stopped, which means I no longer have an infinite loop. I have a finite loop. Let's see. It goes 10, 9, 8, 7, 6, all the way down to 1. So that's because, let's see, so we started at 10, ran the loop, decrement. Then we were 9, still positive, run the loop, decrement. 8, greater than, print 8, decrement. Then we get down to 1, okay? My value, 1 is greater than 0. Print 1, decrement. We didn't print 0 because is 0 greater than 0? It's not. So because 0 is not greater than 0, we skip the rest of the while loop. So I'm going to make a couple of adjustments, make this number smaller, and I'm going to add another print. We'll say print, and we'll say after the loop, and in here we will say before the loop. So this will be a little bit smaller, and we'll see what happens. So we print before the loop, 5, 4, 3, 2, 1, after the loop. So when we were 0, we checked it. 0 is not greater than 0. So we don't decrement, we don't do anything in the loop, we skip it, and we get to the end. So this is kind of the idea where we want to be checking this condition, but whatever the condition is, however we're comparing it, something needs to happen in my value. In this case, because my value is part of our condition. And your condition can be complex, just like it was with the if, or it can be simple, like we have it here. One thing to notice is that with a while loop, with the if, remember we had that else? There's no else with a while loop. It's just the code in the loop or nothing. So there's a few more things that we might want to keep in mind, just to be aware of. What if, instead of doing it this way, I said, okay, what if we just said minus equal 1? If you remember from before, we talked about incrementing and decrementing. This is going to look exactly the same. Perfect. I could also say, while my value is not equal to 0. So we run the code again. It works perfectly. But when you run into these exact checks, we have to be a little more careful. Because if I were to do this, change one character in my code, so instead of going down by 1 every time, now I go down by 2. If I run this code, I get back into an infinite loop. And that's because our first value was 5. Then we subtract 2, that gives us 3. Then we subtract 2, that gives us 1. Then we subtract 2, that gives us -1, then -3, then -5, and so on. This condition is never false because I just totally skip over 0 because of the way I'm decrementing. And I can do this with a lot of numbers. If I do this with 3, I would go the exact same. I skip right over 0. So when you're doing these whiles, you might need to be careful in that not every condition is going to work for you depending on how you change my value. Now there are a lot of conditions you can put in here. Most of them are going to be involving these comparison operators, but it's a really good practice to kind of try out some numbers and see what works and what doesn't work. I'm going to go back to using just greater than, and what if I'm using just the greater than here? I need to finish the job from before. Now we'll run it. And then it actually stops this time. So this is kind of the introduction we have to repetition, and our first repetition structure is the while loop. Remember, it is called a precondition loop because it checks the condition before it runs. In fact, if I were to start out with -1 and I were to run this code before the loop, after the loop, I never even run the loop, because it checks my value is -1 greater than 0? No. So it just skips the loop altogether. So a common thing you'll see with loops are loops will either run forever, which is your infinite loop. They will run 0 times. They will run exactly 1 time, or they will run several times. These are kind of the 4 cases you want to look at when building your loops. Sometimes you want an infinite loop. Sometimes you want a loop that may just never run. There are cases where you would want this. It's not totally obvious, but you definitely want the ability to have a loop that never runs. Maybe there's some condition that you're not expecting to be met except in very rare circumstances. If that's the case, that loop should almost never run. It's going to be the least common. Really, and we'll just kind of move that to the bottom because that's the one you would rarely want. Sometimes you want a loop that'll run exactly 1 time, and sometimes you want a loop that'll run several times. And we break it out this way because a lot of loops really could be multiple of these depending on the exact condition that you start with. So when you're building your loop, a good thing to check your condition for is to try to get all 4 of these loops to work by just manipulating your condition and the way you modify your condition. Because if you can get all 4 of them to work the way you expect them to with 1 loop, then you are in a very good position to kind of guarantee, hey, my loop is going to work the way I expect it to. But the while loop is one such loop. It is a repetition structure. It's a way to get one chunk of code to run again and again a certain number of times or until a condition is met. So this is our first adventure into repetition structures, and we'll see another one in the next video. But the while loop is going to be very similar to an if block. The biggest differences are that 1, this condition gets checked multiple times until it is not true, and if it's never true, then it only gets checked the 1 time, and there's no else to go with it. You can only run the code inside the block. There's no alternative path. You just run the code before the loop, then you run the code in the loop however many times the condition is true, and then you run the code after the loop. So do bear in mind that you can put ifs inside of a repetition structure. You can put else if with another condition. You can put an else. So your if structure can absolutely go inside of a while loop. You can also put your while loop inside of an if structure. So these are kind of building blocks of code, and they can work with each other with different directions of nesting. So they can go in the if. You can also put one inside the else. There's a whole bunch of options here now that when you start learning more and more tools in your code, that there's more and more complex things you can build with them in different ways. You can kind of stack them, kind of like building blocks, right? They go and fit together in all kinds of different ways. So this is another structure for you to kind of work with and play around with and see if you can get some intuition for it as you practice with it.